director of the Solution Architect organization at BAE Systems, Intelligence and Security. We are the part of BAE that integrates, operates, deploys. We do a lot of development, R&D type stuff. We take a lot of the stuff that our dedicated R&D group over in our electronic systems sector builds, and they hand it to us and say, it's TRL5, it's TRL6, and we look at it and go, it's TRL4, but we can make it work. And we end up working with our customers to deploy that to meet your needs. And thus endeth the obligatory corporate ad part of the talk, because they're the ones who paid me to come down and do this. So, following the model I was taught, I'm a lifelong contractor, but I've been working with and for the defense community since the day I stepped out of college. Following the model I was taught by Air Force, Army, Navy people, I'm going to tell you what I'm going to tell you, I'm going to tell you, and then I'm going to tell you what I told you. And if you have a problem with that, take it up with retired Colonel Mark Dinerstein, currently living in Atlanta. What is the Internet of Things? The Internet of Things has many definitions. The top part is Wikipedia's. I like going to Wikipedia as a source for sources, because a good Wikipedia article may not be reliable in and of itself, but if it's going to be argued about and it's going to have a deck of sources at the bottom of it that you can look at, and if people are arguing about it, you can actually go to the history page of the Wikipedia article and see what the religious wars currently are. And if you're a guy like me who likes to stick his nose in the middle of religious wars, that's a fun thing to do. But right now, this is a consensus definition. It's long and it's wordy, as befits the academics who spent most of their time working on this stuff for Wikipedia. But basically, it's things. They connect and exchange data. They do stuff. IoT involves extending internet connectivity beyond standard devices, et cetera, embedded with technologies, these communicate and interact. My simple definition, one sentence so that I can explain it to high school students and high school teachers alike: the IoT is everything that connects to the internet that isn't classical IoT hardware, IT hardware. If it's not a computer, a router, a server, it's probably something that we would call IoT. And for those of you who worry about SCADA systems and control systems and industrial infrastructure systems, worry, because the IoT world and the SCADA world are cross-pollinating faster than anyone is ready for, and that is part of the attack surface. So what is an attack surface? I'm telling you what I'm going to tell you, guys. And if you're all this quiet the entire talk, I'm going to start picking on people. And there are BAE Systems employees in the room who I can pick on, and I will. Every IT system has an attack surface. Those of you who've gone to the cyber school, those of you who've been to DEF CON or Black Hat, you know of this term. An attack surface is all the ways that people and systems interact. If you can do it to or with a system, the potential for vulnerability exists. This is why SQL injection is still such a popular way of hacking into systems. Because every time someone puts together a database system and doesn't write the code or make the call to sanitize the input strings coming from the outside world, you have the potential for a breach. comic called xkcd.com that features a strip with a character called Little Bobby Tables. Google it, it's funny. I didn't include it in this brief because it was already getting long. The attack surface includes all 7 layers of the OSI model. So you can have what you think is a secure application. But if there are network vulnerabilities in the underlying system, your application can be owned. If there are vulnerabilities in the hypervisor or the hardware you're on, your application can be owned. At the same time, if your application has vulnerabilities, those can be used to punch through the layers of protection and take control of the system. And while we have gone to great lengths and we are making a lot of progress in securing our systems, and I have to give credit to Microsoft because 5 years ago I took their name in vain early and often, but those people have spent more dollars on security in the last 5 years than just about everyone else on the planet, trying to get themselves back to a stable state. They have gotten very good at sanitizing their APIs, at bounds checking their service calls, and making sure the I/O that they do meets a contract. That's helped a lot with the operating system layer of the model. And the hypervisor community has spent a lot of time and effort working to secure their layers. So Microsoft's Hyper-V, VMware, there's a lot of attention paid to penetrating those and defending them. So a couple of years ago at DEF CON, there were presentations on how to penetrate hypervisors and get local system admin access to the underlying hardware and spy on what was running in the other hypervisors running on that physical hardware. All of those have been patched now. This is good news for the security community and for the community like us that worries about vulnerabilities, that worries about cyber hygiene. The OSI model includes an application layer, but there's another layer on top of it, which is the layer that hackers and social engineers have the most fun with. The users. What is a phishing scam but a social engineering effort to induce users to behave poorly? There are a lot of those out there. Click here to take a survey for a free Amazon gift card. Click here to see the latest Happy Cat pictures. No matter what you do, you cannot engineer out human stupidity, which is why the security community has to work so hard to fence it in. There's also something that's very interesting to the Army cyber and signal community and to the IoT world, radiated RF. At DEF CON this year, there was a talk called Screaming Channels. It will come up on YouTube in a couple of months. I recommend you take a look at it. These slides had to be prepared before I went to DEF CON, so that's why I don't have a direct site, but I'll tell you now. Integrated digital and analog circuits, radios that generate their waveforms on the same digital circuitry, induce noticeable signals which can be extracted from the emitted RF, and if you can sync with the clock, you can extract crypto keys for standard commercial encryption mechanisms. Takes nice big antennas. They demonstrated proofs of concept, showed it to us at the conference. Based on prior knowledge, I will say that they're pretty darn accurate, but it's now out there in the public world. It's also something that the Army EW community should be able to consider leveraging. The fact that all of these IoT systems have the same vulnerabilities as our classical IT systems, but we're not managing any of these IoT systems the way we spend time and effort managing our IT systems, means that our attack surface just became fractal. Your IT system may have a bounded attack surface, but if you have IoT sitting on your network and you don't know about it, you are in trouble. Home, office, personal environment. Samsung Smartthings Hub. I will talk about this a little later. I'll show you a nice picture of it. It is a hub for your things, for your Internet of Things things. Some security researchers got hold of it. It talks Wi-Fi, it talks Ethernet, it talks Bluetooth. It is designed to plug into your home router directly and control your smart home. It talks with your smart power plug so that you can monitor your power usage on a per plug basis. You can turn lights on and off remotely, etc. It talks with your thermostat. It talks with cameras and security systems. It talks with your smart locks. It had 20 vulnerabilities. Some of these vulnerabilities were subject to chaining. So let's talk about vulnerability chaining for a second. If I, as a security researcher, find an arbitrary code execution vulnerability in a product that a user can get code to run on the product, even if that's only at the user level, that's a certain level of vulnerability. The vendor is going to tell you, oh, they can only run that as a user, therefore the risk is bounded, therefore we'll get around to it in one of our major release patches. If there is another vulnerability that allows a user to escalate their privileges, and it is a separate vulnerability, the vendor is going to look at you with a straight face and go, well, that is a vulnerability that requires physical access to the device. That's unlikely. It is a low-risk item. We will fix it in our next major patch release. If you chain these vulnerabilities together, remote code execution can be used to get escalated privileges, which means 2 vulnerabilities, or maybe 3, or maybe 4, if you're a sophisticated adversary, can be used to own the device and thereby get access to all of the things it's controlling in your home. So let's talk about some Internet of Things things. I'm trying to keep an eye on my clock so I don't overrun too badly. The Internet-connected refrigerator. Does anyone in this room own one of these things? Good, you have sense. You can have an app on your phone, and while you are at the grocery store, press a button, and it will take a picture of the inside of your refrigerator. Plus, it has a touchscreen TV, so you can use it to watch TV and browse the internet, run Netflix movies in your kitchen. I personally have no desire to stand in front of my refrigerator watching a movie on Netflix. And if I go to the grocery store and I don't know what I want, I call my wife or kids and have them look in the fridge. It's why they exist. It has a camera in it. It has a touch screen on it. I personally find these to be a huge waste of money. The smart home. People have been talking about the smart home since Walt Disney did his World's Fair Imaginarium series. And there are truly good things we can look forward to in the smart home if we ignore the fact that we're giving up all privacy. Home security systems being a particularly egregious example of this. The guy who hired me into BAE is not here in the room, but but if he were, I would point to him and tell you never to drive by his home. Because his home has an RF sensor that will track and log every phone that drives by. We can talk afterwards. It picks up the Wi-Fi network that you try to connect with. It picks up Bluetooth. If you pull up close enough, it'll pick up other things. He can tell when his UPS man is out sick and a replacement has come. He has both wired and wireless security cameras. Why does he have both? Because if someone hacks or attempts to hack his wireless security cameras, it sends him alerts and he uses his wired security cameras to make sure what's going on. Every room in his house, except a couple of particular ones, are under surveillance. He's a bigger nerd than I am, and that's saying something. He also has sons who do a lot of the work for him. He just tells them. He's good at delegating now. He's not in the room, I can say that. Cars. Most modern cars have a cell phone built into them. We'll talk about that in more length later. Fitbits and other fitness trackers. Now, the Army community should be quite familiar with this. Your Fitbits report to someone or something. Used to be, it was just, I'm telling you how many steps you took, I'm telling you what your heart rate was. Then we got the smartwatches, the Apple Watch came out, and everybody had to upgrade their Fitbits to be smart. Well, smart means they connect with the internet. Either they connect with the internet all the time through a cellular connection, they connect with the internet through their own Wi-Fi, or they connect with the internet through a Bluetooth link with your phone. And those last ones are hell on wheels to detect, guys. So, the United States military has a lot of highly motivated people who really believe in physical conditioning, and when deployed, they continue their standard personal physical training. And sometimes they compete with each other, both individually and as groups. And this company, Strava, offered a mechanism for them to track that. You could set goals, you could set challenges. What nobody realized was, one, Strava was selling this data. Two, Strava's web interface had a SQL injection vulnerability, and anyone who found that could dump their entire database. The result, hey, look, there are these patches of empty desert that seem to have people running in circles around them. I wonder what Google Maps says is there. Google Maps says, hey, that's an airfield. So note the tweet that says CIA site. I don't know if it is or isn't, but that's what they're saying publicly now. All through a data leak from IoT things we didn't even know we were doing. I believe I just read recently that there's a directive that forces going out to the field stop using such things. Let's talk about everybody's favorite appliance. This is my secondary brain. I use Apple. I use Apple, A, because my wife has invested thousands of dollars in the Apple ecosystem because she's a teacher, but B, because Apple accepts responsibility for security vulnerabilities. If you're running an Android phone, you are stuck with whatever your carrier provides you in the way of patches, and some of them are notorious for orphaning their hardware platforms and not providing updates. So if you're running Android, it is worth it to jailbreak the phone and do your updates from Google and the Android master itself. Because there are lots of vulnerable Android phones out there. But this is different. There is a technology called Stingrays. The guys from the electronic warfare shops should recognize that concept. You set up a dummy cell tower. You have it say, hey, everybody who's around here, log into me. The phones register. And get a whole bunch of information about them, including their location, including what their carrier is, their SIM IDs, etc. A lot of uniquely identifying information. And law enforcement has been using these legally for a while. The Electronic Frontier Foundation would really like to have them file for warrants before they go using them. They also appear to not have a uniform set of data retention and deletion policies across the nation. So if you're into personal privacy, that's a little concern. But there came a point this last year where cell phones were having a real problem around the White House. And a lot of the time when that happens, it's because somebody isn't deconflicting their spectrum use when they set up a stingray. So the cell providers got brought into a room, and the different law enforcement agencies got brought into a room, and when they got finished filtering through those, there were still stingrays out there that no one could account for. So some third party or parties unknown, is running stingrays outside the White House. And publicly, at least, we can't track the damn things down. There have been multiple vulnerabilities associated with cell phones allowing SMS messages to be intercepted. There have been multiple apps in the Google Play Store that turn phones into data logging and spying devices, capturing keystrokes, capturing audio and video. Most of these, when they're found, there's a big brouhaha. Google kicks them off the store, but in some countries they're not allowed to. And then there are the people who provide the service to us, and because we as Americans don't realize the value of our identity, that's a whole discussion we can have later. They sell these things because we are a capitalist mercenary society and we attempt to monetize everything we can. And if you are going to sign a contract with a cell phone carrier, they are going to sell every bit of data about you that they can accumulate while they're taking your money for service. Cell phone carriers sell in real-time location tracking data of various depths, depending on who you are and what their service offering is and what the rules are in your state. California and Massachusetts have pretty good data privacy and protection laws that make them anonymize the data. But if you're out in West Virginia, I believe they can pick up your SIM ID and your phone number in real time with your location. So Brian Krebs, very well-respected security researcher, the guy who more or less invented the term swatting, because on multiple occasions the Fairfax County, Virginia Sheriff's Office has been called to his house with reports of armed individuals holding hostages, and they have busted down his door at least twice and gone in at 2 a.m. and found him and his family snug in their beds. It's a little bit of a nightmare for them, but Fairfax County is never going to do that again. They now have him on record. That's been done by hackers in retaliation for his disclosures. And then we have just plain old spyware campaigns, all targeting phones. Anyone ready to give up this part of their brain yet? There's a vendor down on the show floor that builds a Faraday cage. Actually, they're in the hallway. They build a Faraday cage for your phone. My advice, put it in airplane mode before you close the thing. Otherwise, it's going to spend all its battery trying to connect with the network. The other thing on that location tracking, anybody with the dollars can confirm whether or not you're a member or affiliate of the intelligence community just by accessing your cell phone tracking data and noticing that you pull your car into a certain parking lot and the phone stays in the parking lot for 8, 9, 10 hours a day, repeatedly. There's a little OPSEC hole there. Speaking of your car, Ford Motor Company, since 2009, has built in a fleet management capability for all of their cars, particularly their trucks. I don't know how many of their trucks the Army buys. I don't know if the Army specifies that this system be included or left out. But I can tell you that Ford knows where every one of them is if they want to. They send a signal over to the built-in cell phone, and the vehicle starts transmitting back to them. A Ford executive came back later and hastily retrenched off of his statement, but some of us of a more cynical mindset believe it. We know everyone who breaks the law thanks to our GPS in your car. If you're doing 75 and a 55, they can figure it out. How many of you are with Progressive or Nationwide or Allstate or State Farm for your car insurance? Come on, I'm State Farm. Have you heard them talk about their safe driver discounts? Yes, ma'am.
Yes, and I subscribe to it after doing research, and it's just for one vehicle.
Yes.
Knowing the implications.
You are an informed consumer. However, the guys at the DEF CON Car Hacking Village believe, although I have not seen a demonstration, that they can load malware on those dongles if they can get physical access to them. Now, that's a low-level risk. They have to get into the supply chain of the company. But most of those dongles either transmit data or ask you to periodically plug them into a computer and transmit data. You're being watched. That data will get resold. And it will also determine your insurance rates. But these are worse because these are online, real-time, with the ability to turn off your car. I personally bought a Honda Clarity plug-in hybrid. It gets 50 miles of pure electric range, and then it kicks over into hybrid mode and gets hundreds of miles more. This is the app that comes with it. And I took this picture on July 27th when I had 4,028 miles on my odometer. My car was parked at the AAA store in Frederick, Maryland. I had drained my battery to 3% because I'd been driving a lot that day. So my electronic vehicle range was 0 miles, but I still had 379 miles of hybrid vehicle range off the gas engine that's still built in. The climate control system was turned off, but if I wanted, I could hit the turn on button on my phone, and it would turn itself on and cool the car down for me, because summer is a painful time, winter can be a painful time. Yeah, let's get the climate control system working. I can schedule service. I can do many things to the mechanical functions of my car from my cell phone. And all of this passes through Honda's servers on the way between me and it, so they know all of this data. And if some nation state targets them, Katie, bar the door. I'm not worried that much about me personally right now. Our good friend Elon Musk was at DEF CON this year. He's been at DEF CON for the last 4 years. Tesla and SpaceX recruit heavily at DEF CON because Elon's nightmare is that one of his cars is going to get hacked. He knew about stuff like the Jeep remote vulnerability. He knew that was possible long before. He wants to make sure that's not going to happen to his cars. But when the Tesla Model 3 came out, Consumer Reports liked everything about the car except the braking distance. It had soft, mushy brakes. It didn't brake effectively. A couple of weeks later, Tesla rolled out an over-the-air update to the braking software. Improved the braking distance by 30 feet. Which tells me, A, they released a beta version of the braking software. Please don't do that to my car. B, people inside Tesla can change the behavior of the vehicle I bought. And anyone who either gets into Tesla or can successfully impersonate Tesla can now control my car. All of these are things. The Internet of Things is now surrounding us. And then, really quickly, because I have burned some time, your home network. Brian Krebs has a wonderful article on his website about the value of your hacked PC. Well, your hacked home router is almost as valuable. Your home router is a bridge for botnets. It is a bridge for APTs. It is a bridgehead that they will use for DDoS attacks, for forwarding malware, and very few of those things ever get patched by the consumers. I live in a community where Comcast is my only choice for internet access. I do not use the Comcast-provided router. I am that paranoid. I use my own, and once a month I go out and I force a firmware update. How to check your router for malware. This is out there. When the slides become available, you'll be able to read all the URLs. And then, how to seize control of a router with router sploit. It's plug into Metasploit. Works well by all reports. I haven't done it myself because I don't want to violate my terms of service with Comcast. And I haven't had time to get into the lab. This is the Samsung Home Smart Hub. A tiny little box. But it's going to let me control everything through an app on my phone. Well, it's also going to let someone several thousand miles away control everything through the internet if you don't keep it patched and if the vendor doesn't write the patches. And almost none of the vendors will proactively push the patches out. You have to go fetch them. Most consumers don't even know this is a problem. And then this is the reason I don't have any of these in my home. And Amazon Echo became a VTC system without anybody asking it to. Started recording a family's conversation and streaming it to someone in their contacts. This wasn't something that Amazon had advertised as a capability. It was an error in the voice command system. These things are always listening, and they stream everything back to the mothership. So now that I've scared you, are you all scared? Are you willing to give up your phones? Are you willing to go back to carbureted vehicles? Combinatorial factors generate very large numbers. We have now talked about several technologies in the home, in the office. I didn't even mention printers that generate large numbers when combined. If you are adept in the art of vulnerability chaining, you can say, there are 20 vulnerabilities in that Smartthings Hub. There might be 5 in that home router. The smart fridge, let's say it's really stupid but up to date. It's got 2. Hey, that's 200 combinations right there. I doubt that's all the things in your home. I have heard of vulnerabilities in smart light bulbs. Then you have standard vulnerabilities. Then you have user error, admin. Most people don't know these things are here. Most workplaces can't keep track of them. I have worked in SCIFs where they have discovered IoT things that the person who brought them in didn't know had that capability.
Crockpot. Crockpot's my favorite one for that.
Yeah, the smart crockpot with the Wi-Fi so that you can monitor it. High Point University has washing machines and dryers that text the students when their load is cycled. We've trained ourselves to be dependent on this technology. And even worse, most of your vendors out there don't provide patches. There are an awful lot of orphan island instances of Linux sitting in these embedded devices that either the vendor isn't supporting or the user doesn't know needs to be patched, or there is no mechanism to patch it. There are routers and printers out there that are running cut-down Unix kernels. And printers scare me in general. Recently, some consumer reporters bought some printers off eBay. Turned out to have been owned by a police department. The hard drives on the printers had copies of every document that had passed through the print scan capability. Still, there's a lot of personal information. How can you tell how many IoT things are in your environment? Well, I have a 4-step introductory process. Look for yourself. Inventory yourself. Track the packets, because all of these things do talk packet. And then analyze your world with machine learning. I will say publicly, I am a machine learning skeptic. Not in that I don't think it can do its job, but in that I think what most people are saying, there's a vendor in the hall downstairs who still miffed at me because when they promised me a deep dive on how their machine learning user behavior analytics that didn't require training worked, I went to them and said, well, this looks exactly like the rule sets that we generated. And how is this not just an expert system? And they're still unhappy with me. And we were talking under NDA. They could have opened the kimono fully, but they were unable to. But ML does do some great things. It just takes a huge investment. People don't realize how big and hard ML is. First, look for yourself. Are you in Shodan? I don't know how many of you know what Shodan is. Shodan.io is the Google for IoT devices, where Google runs around the internet searching for web pages. Shodan runs around the internet searching for things. Check your IP range on Shodan. Then have somebody subscribe to it and look at the subclasses of devices. If you are a defensive cyber operator, a regular Shodan survey should be part of your cyber hygiene now that we're in the IoT age, my opinion. If you are an offensive cyber operator, use this power only for good, because this is going to tell you an awful lot of internet accessible things and some of them, it will tell you it's got the default credentials. Where are your things? Do you know where your things are? Do you have an effective configuration management system? Do you understand the role of all the devices that you have in your configuration management system? Do you have set up in your environment rules to cross-reference DHCP, DNS, HBSS, and your firewall logs to make sure that there's not a device that's popped up on your network that's not using your resources? Here's one of the big clues about IoT things. They home outside. They don't belong in your domain. They'll DHCP, and this is how I'm going to show you in a few minutes one of the filtering ways that you can use to filter. You can tell machine learning, look for behavior like this. Can you export that data? If you're going to be using ML, you're probably not going to be using it on your PC unless you have weeks or months to allow things to crunch. You need large amounts of data, and you need a long time for the algorithms to work. A lot of the things that we call machine learning today were actually hypothesized in the 70s, 80s, and 90s, but could not be realized because at the time you would need to chain together all the Cray supercomputers that had ever been built. These days, this has more power than a Cray 1. I have planned space missions around Android phones because it's got all the CPU you need to do the job. Although it does turn into radiation-addled sludge after about a month in orbit if you don't armor it. It is very hard to work with anonymized data when you're using machine learning, because if you anonymize the data, you may be erasing key aspects of it that the ML algorithms need to process. In experiments, I have worked with a couple of different anonymization techniques, and I have skewed my data wildly by simply anonymizing the data. I'll talk about why that is so important. So, another thing Shodan does, Shodan has a database where it classifies the devices it finds based on their responses. You too can use this to classify the devices you find. And you don't have to have an intern or a graduate assistant go out and figure out how to do that because Shodan's already done it. So, phase 2 of identification and classification of IoT using machine learning can take this kind of metadata and use it as a classification. There are papers on the internet about classifying things. Google them. It's a lot easier to do that. But let's talk machine learning. I don't know how much you guys know about this, but if you want to know about it, buy the Green and Black book. The one advantage the Dummies series has is they keep the things updated. This world is changing so fast. Personally, I'd say buy the ebook and get the free updates. There is no shame in having the Dummies book on your bookshelf. I promise you. It's a conversation starter. Go through their tutorials. They have some nice tutorials in this. They'll talk with you about how to work with the programming languages. Here's a clue. If you get to it and you don't want to work with the programming languages, skip that part and read the rest, and know that you're not going to be the guy who's writing the ML stuff. Get a free account on one of the cloud providers. Use their pre-built machine learning libraries. Do not reinvent the wheel unless you're a PhD candidate who has spent his last 2 years doing literature searches. Because like I said, a lot of this research was originally done 20, 30 years ago. Now we have people implementing these things, finding the flaws in it. But there are gigabytes of material on this. Don't reinvent someone else's wheel. In the end, hire a data scientist, hire a couple of good programmers, hire more than that. Building high-quality machine learning tools is expensive. I'm down to 10 minutes. I'm going to start moving fast. Machine learning, point one. This is the introductory workflow for machine learning. You have raw data. You have to turn it into something that the models can understand. You have a set of algorithms. You will not understand them at first. Read what they say they do, play with them, feed them data, see what comes out. This life cycle up to finding the chosen model is months of effort. That's all the labor. Once you have a model, then you can start building applications that use it. What data will you use? Where are your things? This is a scenario graphic, a sample graphic of a generic network. We have a switch with hardwired network computers. We have a wireless access point that everything is coming in on. Hopefully you have a firewall between it and everything else. We have a router. We have a server farm. We have another firewall to get to the internet. What logs are you going to look at to find an Apple Watch? Going to look at the firewall? No. You should be looking at the wireless access point. You should be looking at your DHCP server. Most IoT devices that you're going to be able to detect easily are coming in through the Wi-Fi system. Check your guest networks, but true risk lies on the internal network. This is human error. It is ugly. Switches. Are all of your unused ports locked down? Is there anything coming out of one of those ports? These days, every switch lets you disable access to it, to the unused ports, port level security, use it, standard hygiene. If you are running local VLANs, a lot of them will never make it to the router. A lot of traffic will get routed by a layer 3 switch and never hit the router and never hit the firewall. So if an IoT device is happy talking internally to other things, the traffic will never show up on your external logs. Your routers are still important. They give you patterns of behavior. They let you know when things are talking with the Internet of Things. The routers are also where most of your subnets are defined. If you have traffic spanning internal VLANs, that's where the routers get to it. Although I built an entire system where all VLANs terminated on a firewall so that we could enforce some really strict rules. Your firewall logs are critical. If you have an outlier, go look at Shodan. If your firewall says that there's something strange going on, make sure it's not a printer. DHCP and DNS, are there rogue devices in your DHCP? So DHCP is allowed to let anything, is designed to let anything that comes up get an IP address. Is that changing? Are there devices going out of your network without hitting your DNS server? There are devices out there that generate their own IPs. There are devices that are designed to go use OpenDNS or Google's DNS. Deep packet inspection. Many, many things are tunneling through port 80 or port 443, which means if you can't figure out what it is from the externals of the packet, you need to look inside it. You can no longer trust that a protocol is a protocol when everything is tunneling through the web interface. If you have the technology and the permission, break the SSL. Cellular connectivity is now built into many of the IoT devices, particularly the cars. I have to put this in here. It is not legal for civilians to stingray things. This got Ninjatel in trouble at DEF CON a few years ago. They're now out of business because they got tired of their legal bills. However, many of you in the room are members of an armed force which has its own authority, and the electronic warfare people should be able to watch everything that's going on here. Applying machine learning to find the IoT. Take your raw data. You've got two types of raw data that you're going to want to mess with. I'm going to focus on PCAP right now. syslog is the other primary source. There is a problem in that syslog varies by vendor. So you're probably going to want to take your syslog off your logging servers, which means, Splunk reports, ArcSight. Please tell me you're not using ArcSight. Conversation for later. So I have a DHCP PCAP up here. I have a standard DHCP anonymized PCAP or syslog. Applying machine learning to this data. The first thing you have to do is format the data for the algorithm you're going to use out of that original thing. So, this is a call and response for DHCP, the externals of the data. Then you apply your machine learning algorithms. You train it, you score it, you examine your results, and you iterate because you never get it right the first time. Extract, translate, and load. I'm talking fast because we're running out of time. I've rambled too much. You haven't been strict with me on the clock. Data gets to you in many forms. How did you get your logs? Are all your logs going into the same place? Please tell me they are. Can you get a single report in a standard format? Odds are no. Your chosen algorithm will want it in a specific format. Machine learning tends to like tables, where you have rows, columns, depth. These can be n-dimensional arrays and tables, deep matrices, depending on the algorithms you're using. So there's been this thing called extract, translate, and load running around for about 30 years. We've gotten really good at it. You extract data that you care about from different input types. You translate it and load it into your target output. When you're dealing with big data, this can be 30 to 50% of your processing. Just getting the data out of the raw data stores, turning it into something you can actually reason on, and then feeding it. Picking your algorithms. Effective machine learning is not picking an algorithm. It's usually picking a chain of algorithms with decision logic around them. This is Microsoft Azure ML Studio. It's nice, it's convenient. I've played with it. All the cloud providers have their own stuff. This one requires the least knowledge of higher math. So let's talk about classifying your network. Clustering algorithms can be applied in several different ways to identify clusters of similarly behaving things. You can cross-correlate your DHCP versus your internal source IPs, your DNS versus your external IPs. Have there been DNS transactions for all the external IPs we're going out to reach? And if so, why not? Or if not, why not? Your traffic dynamics. You have talkie hosts, you have stealthy hosts. You can build connectivity graphs. So here is an example of IP addresses clustered in clustered in IP space. This is a made-up example that is representative because I wasn't willing to fight the wars to get permission to use the actual data. So this got turned into PowerPoint graphics. Y'all are going to have to deal. This is a 2D plot based on the standard ports and IP addresses. And I'm giving you some of the answers already to shorten this. Yellow are the orange at the bottom are Exchange. The blue are SharePoint. The green are Active Directory. The orange in the middle are load balancers. The red are the firewalls. And the gray, user application, virtual machines. That's your app farm. Your brown are your file servers. The two purple are print servers. And the yellow are believed to be endpoints. This is an initial classification and clustering. So let's look at what their traffic says. Each of the endpoint communicates with the other system components, apps, and the internet. So that endpoint talks with Active Directory, it talks with a load balancer, it talks with SharePoint, it talks with Exchange, it talks to a printer, and it goes out and it talks with the firewall. And I can say, hey, that looks like a typical endpoint. I've classified it. I'll move to the next one. And you iterate through. This also looks like a typical endpoint, although it's using an awful lot of the applications. I have finished classifying almost everything else, but here's something, and that the different clusters, wired and wireless, I didn't tell you that earlier. You don't really need to know it. But this is one that grabs a DHCP, because I've got my AD servers doing DHCP, and it does a DNS request off my load balancers, and then it talks with the internet, and it doesn't talk with anything else inside my network. I have an outlier, ladies and gentlemen. What have I just found? Well, I'm now going to have to go through an exercise of tracking back to the wireless access point that this thing came in from. I'm going to have to go through all the things in the area, or I'm going to have to look at the PCAPs and find out what exactly it was talking out to the rest of the world to do. What I found was that a well-meaning member of the staff was tired of the nag screen from the Vizio Smart TV that had been installed in the conference room and logged it into the network. All that effort to find one thing. How many of these things are in your networks? And how hard are they to find? Once you have done that, dig into the internals. I used to really do a lot of deep packet inspection stuff. I love it. But it's another order of magnitude of processing that you have to deal with. In summary, machine learning is a tool. Add it to your toolbox. Don't expect it to cure cancer. IoT is with us, like fungus. It's going to stick around forever. We are addicted to our devices. The younger we are, the more addicted we are. We're going to have to deal with this and manage it forever. What's worse, things that we didn't used to associate with internet connectivity are now reporting on themselves without us knowing about it, like our trucks. And those of you with a paranoid frame of mind and who have access to electronic warfare equipment can think about what that could mean in the future. There is a complete and utter lack of product liability out there. When you buy it, you're assuming all the risk. If your phone gets hacked because Verizon hasn't updated the Android OS, it's still on you. They're a law firm with technologists sitting at the bottom. you can't get them to assume liability for that. So, those of you in this room, check for firmware updates early and often. Be educated consumers and figure out how you're going to handle these things, because they're not going away. Machine learning lets you do analysis and insight, but it is its own discipline. It is not just something you can assign a computer scientist to. This requires budget. This requires focused effort, and you need to have targeted outcomes in mind before you start your investment. All right. I am at an hour, well, I'm at 59 minutes since I started, because we started about 5 minutes after. Does anyone want to try to ask me a question in that time? Yes, ma'am.
I didn't hear anything you said about the smart TV.
So,
A couple of slides ago.
yeah. So the reason this is sitting here is because someone got tired of seeing the "I'm not set up properly" nag screen from the new Vizio Smart TV that had been installed in a conference room and logged it into the building Wi-Fi. We introduced a security vulnerability to an uneducated user, adding a device to our network. Now, the fact that it was sitting there screaming to be added to a network is its own issue. Other questions? Yes, sir.
Yes, sir. What's the acceptable batch size to train your model that you found? And in your experience, what's the learning rate that you applied to that?
It depends on the algorithms you're using. So if you go out and research the different classification and clustering algorithms, if you use Bayesian, usually you'll need several hundred points. The bigger, the better. And you can get up to about a 94% accuracy on just based on IPs and ports and a little traffic. But the answer, it depends, underlies everything in machine learning. So many things can be thrown off by changing just one little variable. The way these models are built, each class of model is different from the others. You can feed them all the same data, but if you change the preconditions, you get widely differing results, which is why iterating is so important in these. So my first recommendation is, before you try doing anything yourself, go spend a couple of hours, a couple of days, Googling what you want to do, reading the existing papers on the topic. A lot of them come out of India and China, but read them anyway. They will tell you what they've done, and they're usually pretty blunt when they make mistakes. Yes, sir.
It appears that the single greatest threat we face is that most security is based on rules written for known PCAPs, and we're depending on a finite number of humans to contribute rules through talents or emergent threats. And while we ramp up the human's capability to write rules for machine learning, we've got a real vulnerability to pack us really on the floor in the unknown.
It is.
Operation correct?
That is fundamentally sound. We have, and so once again, I'll wave this phone in the air. This phone doesn't communicate over a single band. It has 3 different radios in it. It talks near field, it talks Bluetooth, it talks Wi-Fi, it actually talks 3 different types of cellular. It'll fall back to 3G, it'll do 4G, it'll do LTE. That's 3 different radio sets. It's all software-defined radios.
Could we discern if you're calling on Stingray right now? We're looking
No.
at taking in our phone.
Actually, if the Stingray is being operated by experts, you'll never know it. If the Stingray is being operated by a hobbyist, your call will drop. Or I won't say hobbyist, but I will say your average non-federal law enforcement agency, you've got a pretty good chance of a call drop. Because those guys know how to make it do what it's supposed to do, but they don't know how to make it not intrude into the cell carriers. Most federal organizations have been yelled at by the carriers enough that they know how to make it work without intercepting calls. One of the problems around the White House was calls were dropping on both AT&T and Verizon. Now, somewhere in that time, I start thinking, okay, we're going to want a couple of signals intelligence trucks rolling down the streets, grabbing every cell emitter, but there are an awful lot of them in downtown DC. They're using very small cells in order to handle the population density. Therefore, they're hanging off buildings. So, honestly, the Stingray thing in DC, it's about time. You know, it's not that I didn't think it was happening, it's that, hey, it made the Washington Post. Yes?
So I think, kind of, to tag on with that, one of the other biggest problems, and you mentioned it in your slides, and it's due to the user, is
Yes.
people just don't care. They're like, Google can know my location.
Yep.
So what would you, if you're talking to a group of people trying to convince them, because I think you're in a friendly environment here, to go do some of this stuff, what's your doomsday scenario for IoT unsecured?
My doomsday scenario is that a good chunk of the IoT gets turned into denial of service devices, and the rest of it gets used to tunnel into what we thought were protected enclaves. And that the externals, okay, I'm standing in a room with people who know the rudiments of electronic warfare. If you are driving a convoy of trucks that all have cellular emitters built into them that are pinging GPS actively, what can an EW group do in terms of force targeting? You know, gentlemen, is there an A-10 or a Predator available to fly to these coordinates? Because there are 12 pickup trucks driving down this road, and we know they're not ours. You know, that's the simple and easy scenario that first comes to mind. If you have these things inside your boundary, they're going to bypass most of your controls. And if they're outside your boundary, they're going to get used for other nefarious means. And while we've gotten really good at fighting denial of service attacks, the potential for scale is very dangerous. Other questions? I think I've met the time requirement for the CEU. I know the first day there was a little discussion of that. If anyone would like to communicate with me in the future about this stuff, I'll be standing up here for a little while. I don't know if y'all have another talk scheduled here. It's noon, so I imagine most of you want lunch. Comments are appreciated. I know my presentation style doesn't always make everyone happy, but I have to be able to live with listening to it myself. Thank you.
I'm very impressed with your talk.
Thank you.
Very nice job. Do you have a business card or something that I can somehow track